Hello everybody. Today we're going to talk about U-substitution. Here we have an integral, an antiderivative. I would love to remember what the antiderivative is trying to do. This is the derivative of some original function. Where does that come from? What is the name of the original function that it comes from? The way we're going to attack this is called the U-substitution. The reason being is we have this very complicated parentheses power to deal with, and where that comes from I'll kind of show you as we go step by step through the process. So the way I handle a U substitution is over here on the side I pick my U. Now how do I pick my U? There's a bunch of ways of picking U. The typical but not guaranteed. I can't guarantee anything when it comes to integration. It's all about best practice. The typical way or best practice would be what's inside the parentheses. So let me try it. If it doesn't work, that tells me I didn't pick the right U. So I'm going to pick my U to be the inside of the parentheses. Do I always pick the inside of the parentheses? Not always, but almost always it works. So the U is the inside of the parentheses. So that's U to the 10th. It's a direct substitution. I like to line them up. Now, what I like to do is then, all right, obviously 3x just comes down because 3x is 3x. I didn't pick that to be U. dx, well, I need something similar to dx. See, I was integrating in terms of x because that's the variable of usage, the variable of integration. I need to change that dx into du. I do that by our substitution. The technique I do is the following. I state the derivative of u would be du dx, as we know from implicits. The derivative of the right-hand side in terms of dx is 8x. And then I multiply the dx over to make this equation. So again, the derivative of u would be u prime, that is 1 du dx. The derivative of the right-hand side would be 8x. I multiply the dx over and I get this expression. In shorthand, u derivative is du. Derivative of this side is respect to x, and that's why the dx. All right, notice, I need to know what dx is equal to. Well, look at that. dx. All I got to do on my final little algebra is divide this back, and I see that du over 8x is dx. du over 8x is dx. So with these 3 steps of algebra, or really just 2 steps of algebra, I know what dx is equal to. du over 8x. Now, this is the technique I use. There's other techniques. I like this way because I like to see what comes next. I know I did a good U substitution, a valid U substitution, if everything on here is just in terms of U. You might be saying, well, wait a minute, there's X's. The answer is, well, think carefully. Pause for a moment. This is an X times something divided by X. So honestly, the X's cancel. That tells me I really did a proper U substitution. If one of these do not cancel, I didn't do it right. I have to go back to the drawing board or use a different technique. I'm only going to use U sub here. There are so many other techniques of integration you could try. I'm looking for the U sub. So the U sub worked because the X is canceled. If, for some reason, that was a 4th power out here, and I brought this down, well, these don't cancel. That tells me a U sub was probably not the technique, and I should try some other technique. So back to my U sub. All right, the x's cancel. We have a constant rule when it comes to integration. Look at my previous videos for integration. The constant is 3 over 8. That gets pulled out. The constant multiplier gets pulled out. So 3 over 8. 3 divided by, that's a division. 3 divided by 8 goes out in front. The x's cancel one more time. And look where we're left, at a very, very simple integral, antiderivative. If it is not a simple antiderivative, you've done this wrong. All right, a U sub should make things simpler so you can attack it with some other rule that you have up your sleeve. In this case, I got the power rule. So I'm going to integrate this with the power rule. The integral of u to the 10 is u to the 11 divided by 11. Recall the rules of integration. Add 1 to the exponent, divide by that number, the power rule of integration. Please recall there is a plus c in your integration, all right? So these are all equal to each other. They're All right, and understand when you anti-differentiate, there is this plus c, because the derivative of a constant is 0, and you wouldn't find it without a point. So I'm almost there because I have integrated. I did find the antiderivative. The problem is it has a u in it. The original problem had x's in it. So your last step is to re-plug back in. Allow me to multiply, by the way. 8 times 11 is 88. And what we have is u. Well, u is 4x squared plus 8 to the 11th plus c. And so this is my actual answer. And the great thing about it is if you're really good with derivatives, if you take the derivative of this expression, it better be right up there. That's the cool thing. If you're really good with derivatives, if you take the derivative of this expression, it should be right there. That is, bring the 11 down. That gives you 33 over 88. Got it. This to the 10th. Well, we have that to the 10th, right? 4x squared plus 8 to the 10th. Awesome. Remember, chain rule, take the derivative of the inside is 8x. The 8x and 11 make 88. The 88 and 88 cancel. We're left with 3x. So what I like to say is that the U-substitution undoes the chain rule, because that's what I did here, is I undid the chain rule. To take the derivative of this, you need a chain rule. Think about that. Parentheses power, that is a chain rule for derivatives. The U-sub is our technique to undo the chain rule. There should be an opposite operation. Chain rule for the derivative, U-sub for the antiderivative, the integral, whatever word you want to use. How does the U-sub work? Well, here it is. So what you could do is pause the video and then play it through slowly to make sure it makes sense. I'm going to go through a few more examples now, but I wanted you guys to have at least the typical technique. And again, I do not like changing back techniques, so you're going to see me do it the same way over and over. Why is it called a U-sub? For the obvious fact, I'm using the letter W. You can call it a W-sub and just use the letter W. I don't care. It's called a substitution technique. We typically use the letter U. Cool. All right. So let's do it again. And that's really what it comes down to. Now it's your turn to practice. Your turn to try these out. Now that you have the game plan does not change for these. I want to make that clear. The game plan does not change for these. So I got a couple preloaded questions from my note card here. Let's try out a new one. Let's try 5x cubed in the numerator over the square root of x to the 4th plus 10 dx. So I want to do this antiderivative. Okay, I state we're going to follow exactly the rules from the previous example, just one small tweak. Understand we have a radical. Whether we take the derivative or the antiderivative, we should rewrite the radical. So in fact, I have a medium step. I'm going to rewrite this as x to the 4th plus 10 to the power of 1/2, because, as you should know, the square root becomes 1/2 power. And to be very clear, I know I'm not right yet, because it's coming from the denominator, it's a negative 1/2 power. So this and this expression match. I need you to pause and make sure you see this. So now what you should also do is pause and try to do the steps I've done previously before I do them myself, because I'm going to follow it exactly the same game plan. That is, according to our first try, this was u. Let's do it again. X to the 4th plus 10. And so then the derivative du dx of this side turns into 4x cubed dx, as per the previous example. I'm just following through with the exact same technique. Derivative of u is du dx. Derivative of this side is 4x cubed. Multiply the dx over. Solve for dx by dividing over the 4x cubed, and we get our dx. Just like the previous expression, and yes, it works a lot like that almost all the time. All right, what's next? Back over to here. The u-sub, this was not substituted for, so that just drops down. I am bringing u to the negative 1/2 because I picked the inside of the parentheses. My dx has a match, du over 4x cubed. So I got my match. Dx is this. U was picked as this, and this is just a leftover. I'm bringing it down. Now, I notice that both sides, I can cancel the x cubes. If I couldn't do this, again, it's not a U-sub, it's some kind of advanced technique you can learn about, all right? But the x cubes do cancel, and that's awesome. The x cubes cancel means this is a perfect good U-sub. Now, here's an obvious thing. We're teaching you about U-subs. I'm going to make it obvious. So, the x cubes cancel. Pull out the 5/4. And we're left with a basic power rule integral again. 5 divided by 4, pop. The x cubes cancel. Nice. And we have this expression. Now what do? The power rule. Add 1, divide by that number. So what we have here is okay, I got to be careful on my math. Add 1 makes it a positive 1/2, and we're dividing by 1/2 plus c. Last but not least, plug in what u was and you're done. Now I'm going to do some algebra too. 1/2 flips and multiplies, okay? 1/2 flips and multiplies. So that really is, what is that, 5/2? When you do the math there, 5/2, bring this down, 5/2. The u, remember what the u was, x to the 4th plus 10 to the 1/2 plus c. I always like to pause to make sure I've done this right. 1/2 flips and multiplies, makes 5/2 when you flip and multiply do the 5/4. U is u, so that goes in there. 1/2 is that. Again, the good news, if you take the time to take the derivative of this, you should get back to that. If you take the derivative of this, look at that, guys. It's a parentheses power. The derivative of a parentheses power is a chain rule. Once again, the U-sub is undoing the chain rule. And that's the pattern to these problems, is if we see a parentheses power, that's what I focus in on. If I see a parentheses power, it's a pretty good chance it's a U-sub. Are there other techniques? Yes, there are other techniques out there. But it is a pretty good chance that it is a U-sub. And so you try it. If you fail, oh well, try another. And honestly, you could have picked the wrong U. It could have been a U-sub, but you picked the wrong U. It's all about trial and error when you get into advanced integration, and you just got to be willing to try and error. And in this case, the trial, I know I'm leading the right way because I cancel the x's out. And notice x cubes cancel, and that's why I knew my technique was working. All right, guys, thank you for watching this video. Please look forward to watching others.